Circuit designing can be pretty daunting, since the things in reality will be different from what we read in textbooks. Designing circuits takes a lot of reading and practice. In this video, we are going to see 10 tips that can make your design a lot better. We will see brief explanation about these tips here, and I strongly recommend to go through the links in the description once you're done watching this video. Here you will find the sources to detailed explanation on these tips. I'm Frank Donald from Gadgetronics. Let's get this started. Tip number 1. Usage of coupling and decoupling capacitors. Capacitors are pretty handy components used as timing elements or as filters. When using it as a decoupling capacitor, we need to connect them in parallel with the power supply. You might ask why we do this. Well, power supplies of any kind is not perfect. The output from these will be fluctuating in nature. Adding a decoupling capacitor will prevent these fluctuations from the power supply to reach the digital pins. It is often suggested to use big electrolytic capacitor near power supply and ceramic capacitor near the chips. Coupling capacitor, on the other hand, should be added in the path of a signal. This will eliminate low frequency or DC noise from the signal. This is widely used in amplifiers and high-speed circuits. Value of a capacitor depends on the frequency we need to allow. Capacitance value decreases as allowed frequency goes up. Tip number 2. Using pull-up and pull-down resistors. In digital circuits, we often want to feed input using switches or push button. When doing that, we are running into the risk of leaving the input pins into a floating state. Floating state is where input pins of a chip cannot detect input logic and ultimately lead to unexpected output. In order to avoid this floating state, resistors of specific value is used. These are known as pull-up or pull-down resistors. Pull-up resistor connect the input pin to VCC, making it to read logic 1. Pull-down resistor connect the input to ground, making it to read logic 0. Tip number 3. Discharge time of batteries. When you want your design to be mobile, you need to power it with batteries. The most important step while doing this is to calculate the discharge time of a battery. This is because if you attempt to discharge the battery capacity more than a defined level, your battery will be permanently damaged. As a rule of thumb, you should always choose a battery with 1.5 times more capacity than your circuit's actual consumption. Although this might slightly vary with your battery chemistry, so you might want to check its datasheet. If your circuit requires 1 ampere for an hour, then you should probably choose a battery with capacity of 1.5 amp hours in order for long-lasting battery life and optimum performance. Tip number 4. Watch out for resistor wattage. Almost every designer puts some good amount of time to figure out the resistor values that goes into their circuit, but wattage rating is often ignored. Wattage rating of a resistor means the maximum amount of power a resistor can safely dissipate in the form of heat. If the dissipation in a resistor exceeds the maximum wattage rating, the resistor is likely to fail and smoke. You can find different wattage resistors for a given resistance value. Higher the wattage rating, bulkier the resistor will be. Hence, pay attention to the power dissipation in a resistor and choose the resistor that fits your need. Tip number 5. Usage of microcontrollers. Circuit designers often overkill their design by using too many components rather than using a microcontroller, which will make their life lot easier. Many modern MCUs comes in small package with inbuilt features like timers, ADC, counters, serial communication, I2C, SPI and so on. So next time combine your analog hardware with right MCU and you will see better cost versus performance benefits. Tip number 6. Using transistor arrays. This video will be incomplete if we leave transistors out. Transistors are widely used to turn on or off a load and amplify signals. When using it as a switch, there might be instances where your transistor couldn't provide enough current to turn on the load. In such cases, you could use a Darlington transistor, which is shown here. These Darlington pairs have high current gain in the range of 1000, which is quite greater than the gain of a single transistor, which will be around 100 to 200. This makes the Darlington transistor more sensitive to input-based current and operate loads quite easily. Tip number 7. Using PWM signal to save power. You probably might have heard about PWM. It is a modulation where the duty cycle of a pulse is modified. Using this PWM signal, you could drive LEDs or motor, which ultimately can reduce the power consumed by them. This is possible since LEDs and motors are quite slow to react to a high frequency PWM signal. When a PWM signal of 70% duty cycle is supplied to drive a LED, current flows only 70% of total time. Therefore, power consumed will be 70% of calculated power, which means 30% of power is saved. Tip number 8. Individual traces for signal references. When you design a PCB or wire a circuit, provide individual traces when connecting different signal references back to the ground or common node. Avoid interconnecting references together and then connecting it to the common node. Doing so will result in a humming sound or noise in analog amplifiers. This also applies to wiring of input or output jacks, tone and volume controls, and switches. Tip number 9. Choosing the right components. Selecting the right part for your circuit design can be tough since there are plenty of parts available in the market. Designers might often stick to the component they have in the inventory or the one they have used in previous designs. Doing this might work, but the design will not be optimum or the circuit might not produce desired result. To help us with part selection, many component vendor sites like Mouser, DigiKey, Arrow Electronics and much more has advanced part search feature. This feature will allow you to choose your specification from the available options and you can see the parts that fit your selection. You can further refine your search by choosing more specifications and buy the parts from there directly. Tip number 10. Understanding the building blocks. Circuit designing is pretty much like a game of Tetris where you fit in individual blocks of different sizes to win. Likewise, in circuit designing, you should be aware of individual blocks and its functions and then put them together. Some of these functional blocks are voltage dividers, RC elements, RLC elements, amplifiers, multivibrators, switches, Darlington transistors, rectifiers, regulators, registers, multiplexers, and so on. Having a clear understanding of these blocks is really necessary to build your desired circuit. So understand these blocks and combine them in an appropriate way and practice a lot. That's it with the tips for now. There are probably tons of other tips regarding circuit designing that we have missed in our video. If you got a tip, kindly post them in comment section below so that it will benefit others. Hit the like button if this video was useful to you. Do post your feedback in the comment section below. And consider subscribing our channel. We publish tutorial and project videos regarding electronics on weekly basis. Share this video with others and spread the word. Check out our other tutorial videos here and thanks for watching.